Kia ora koutou. This question's for Arpith and it's a disguised quadratic. Now the schedule for this paper had this done in two ways, and one of them was doing it with iterative methods, which I find kind of weird, but I guess you could do it that way, but it's just not actually that complicated. But because I had both methods in the schedule, I'll talk through the second method. So looking at it in here, we can see that we've got a fraction, so 2 e to the x plus e to the negative x over 2 plus e to the x equals 3. So we've got a little bit of like year 9 algebraic fraction rearranging to start with. So let's just start by doing this. And then we should be spotting pretty much straight away that that's a disguised quadratic. Okay, and the way that that falls out is, well, first we're going to group up the like terms. So let's get it to equal 0. So we've got e to the x, once we subtract this, plus 6 minus e to the negative x. Now, if you're just looking at that for the first time, you might not notice how it's going to turn into a quadratic. But let's write out this bit with the negative power and see what we can do with that. So we've got e to the power of 6, e to the power of x plus 6 minus e to the negative x. But e to the negative x is 1 over e to the x. So if we multiply everything through to get a common denominator, here we get e to the 2x, here we get 6e to the x minus 1, and that equals 0. So multiplying everything through now by e to the x, we can just work with the numerator. So 0 is equal to e to the 2x plus 6e to the x minus 1. If we let u equal e to the x, that gives me 0 is equal to u squared plus 6u minus 1. So that's not going to factorise. And also you were told to find it to 3dp, right? So we probably don't expect it to. So we've got u plus 3 squared, take away 9, take away 1. What does that give me? Of course, you could do this with the quadratic formula, right? So we've got 10 is equal to u plus 3 all cubed. So u, which is e to the x, is equal to, what have we got? Negative 3 plus or minus the square root of 10. But we know that e to the x has to be positive, right? So there's my graph of e to the x. So e to the x is equal to negative 3 minus root 10 is not valid. That means that we've just got one solution, and that's e to the x is equal to negative 3 plus root 10. But we're not quite done. We need to take logs of both sides. So e is equal to the natural log of negative 3 plus root 10. And when you chuck that into your calculator, you'll get x equals negative 1.818. Kind of weird that they asked for 3dp instead of 3 significant figures, but there you go. Right, now let's have a look at how we could also do this using iterative methods. I'm not going to do the whole tedious iterative methods thing, but we'll start it off. So we started with this. And remember, iterative methods will work when we're kind of desperate, and when we do it, we're going to try and make x the subject. So doing our first cleanup as before, the first steps are going to be very similar. What am I doing now? So suppose that I just wasn't getting anywhere with spotting that it's a quadratic. Let's just leave the e to the negative x there, and here we've got 6 plus e to the x. So I can do a couple of things here. If I take logs of both sides at this point, we're going to get negative x is equal to the natural log of 6 plus e to the x. That gives me x is equal to negative log of 6 plus e to the x. So that's going to be true at the root and nowhere else, but we can use that to build our formula for iterating. Now I haven't checked to make this, to check that this works, but this is the one that was given in the formula, in the mark sheet. So once you start iterating on that, you should also end up at x is roughly equal to negative 1.818, right? But life is short, so I'm not doing that part of the video. Feel free to play with it. Let me know if that rearrangement doesn't work, but I think that should converge to the same place. So there you go, much easier to do it, I reckon, with a disguised quadratic, but always good to do some revision of iterative methods before the exam on Monday. Thanks for watching. Arpith, thanks for asking for that question. Remember, guys, to send in any last-minute little questions that you've got, and I'll try and YouTube them.